Welcome back to The Explainer. Okay, today we're doing something a little different. We are conducting a ruthless, zero-mercy performance review of a material that has literally shaped human civilization for millennia. No nostalgia points awarded here, folks. We're looking at element 50, tin. You know, that soft silvery metal famous for its corrosion resistance and, well, for quietly holding all our modern tech together.
Let me ask you a question. What metal is so physically weak that you could literally just take a pure bar of it and bend it with your bare hands? I mean, on its own, it offers basically zero structural support. And yet, this exact same metal is so absolutely essential that without it, your smartphone, your laptop, the entire global digital infrastructure would just instantly fall apart. Think about it like this. If iron is the metal that builds our world, and copper is the metal that conducts its energy, then tin is the metal that actually connects the whole shebang together.
So let's dive right into this. Here's our roadmap for the explainer. We're going to start with the quiet connector metal, move into forging the Bronze Age, then break down its softness and solderability specs. After that, we'll look at powering modern electronics, its flaws and supply risks, and finally, we'll give it the final tier ranking.
All right, Part 1, the quiet connector metal, an introduction to element 50.
So let's get the baseline facts straight. Tin is a post-transition metal, atomic number 50. It's got this classic silvery white look, and it's incredibly soft and highly ductile, which basically just means you can stretch and deform it without it snapping or losing its toughness. But here's the absolute crucial thing to understand about tin. It is rarely the star of the show. It's primarily used in alloys, coatings, and chemicals. It doesn't really stand alone, you know? It protects, it enhances, and it bridges the gap between other elements. Honestly, it's the ultimate team player of the periodic table. Moving on to Part 2, Forging the Bronze Age, a 5,000-year historical resume. Okay, let's look at tin's track record, because it's wild. Around 3000 BCE, humanity figured out that if they alloyed this super soft metal with copper, they could create bronze, a material so utterly game-changing that we literally named an entire era of human history after it, right? Then, fast forward to ancient Rome. Tin became the absolute backbone of their pewter tableware and their coinage. Hop to the 19th century and tinplate, which is really just tin-coated steel, completely revolutionized human survival by making safe, long-term food preservation and canning a reality. And today, from the 2000s right up into the 2020s, it's been the driving force of the electronics revolution as the main ingredient in lead-free solder. So it hasn't just survived for 5,000 years, it has actively enabled massive technological leaps in every single era it touches.
Which brings us to Part 3, softness and solderability specs, evaluating tin's engineering properties.
Looking at its engineering traits, tin has this really fascinating dual nature. Methodically reviewing this, its ductility is extremely high, meaning it's highly workable, but yeah, it's way too soft for any kind of structural use on its own. But check out the next two specs. Its corrosion resistance is absolutely excellent, making it the perfect protective shield for weaker metals, like steel. And its alloy compatibility, outstanding. It forms incredibly strong bonds with a huge variety of other metals. And finally, its toxicity is relatively low, especially compared to historical alternatives like lead, which makes it safe for things like food packaging. So, sure, pure tin might be physically weak, but its real superpower is how perfectly it protects and combines with the world around it.
And this brilliantly illustrates the real magic of tin. 232 degrees Celsius. That is its exceptionally low melting point. And guys, this exact number is basically the key to modern technology. Why? Well, when you're building delicate computer electronics, you need a metal that can melt and act as a conductive glue to connect components together. But you need it to melt at a temperature low enough that you don't instantly incinerate the fragile circuit board right along with it. At exactly 232 degrees, tin hits that perfect, absolute sweet spot.
Okay, Part 4, Powering Modern Electronics, tin's current role in the economy. Take a look at this number, 300,000 to 350,000 tons. That is the global annual production figure for tin right now. Now, in the massive, sweeping scale of global commodities, that is a relatively tiny volume. But that's exactly the point. It proves that a metal doesn't need to be produced in massive iron-level quantities to be an absolutely critical bottleneck for human survival and tech progress. So just how ubiquitous is this low-volume metal? Well, its undisputed primary use today is in that lead-free solder we were just talking about. It is quite literally connecting the circuits in whatever device you are using to watch this right now. Beyond that, we're still relying heavily on tin plate packaging to preserve our food. Chemically, we see it in organotin compounds, which act as vital stabilizers and catalysts. It's providing protective coatings for steel, and yes, we're still actively using it in advanced alloys like bronze and bearing metals. And here's a huge trend right now. We are seeing a growing recovery of tin through urban mining and e-waste recycling. That's stepping up in a big way to help meet the immense, unyielding demand from the electronics sector. All right, time to get a little ruthless. Part 5, Flaws and Supply Risks, Areas for Improvement. There is a really dangerous contrast going on here. On one hand, tin is the vital connector for all our modern electronics and an irreplaceable, low-toxicity food protector. But on the other hand, our global dependence on it is shockingly fragile. The supply chain is heavily concentrated in just 3 regions: China, Indonesia, and Myanmar. And because of its relatively low overall production volume, combined with that extreme geographic bottleneck, the market is subject to some insanely high price volatility. So its indispensability, mixed with this fragile supply chain, that represents a massive global risk. And let's not forget, the material itself has some pretty serious physical flaws. As we said, pure tin is completely non-structural. You simply cannot build a bridge or a skyscraper out of the stuff. Plus, it suffers from this really bizarre phenomenon known as whisker growth. Basically, tiny microscopic hairs of metal can just spontaneously sprout from the tin surface and cause devastating short circuits in sensitive electronics. Crazy, right? Also, because of its high cost and market volatility, it's facing intense substitution pressure as manufacturers frantically look for cheaper alternatives. And finally, while pure tin has low toxicity, certain organotin chemical compounds actually carry severe environmental risks. So look, tin is an incredible specialist, no doubt, but these physical and chemical limitations absolutely prevent it from being a flawless S-tier material. Which finally brings us to part 6, the final tier ranking, grading element 50. Okay, let's look at the report card. For historical and tech impact, it scores a massive 9.0 out of 10. I mean, it literally named the Bronze Age and enables all modern tech. Hard to argue with that. Workability and shaping, that gets a near-perfect 9.5 because of how wonderfully ductile it is. Versatility and lasting relevance both pull really strong 8.5s for its vital roles in soldering, coatings, and packaging today. However, mechanical properties drops down to a 7.5, mostly because it relies so heavily on being alloyed to overcome its natural softness. And scalability and cost is its lowest grade by far, dragged down to a 7.0 by that highly concentrated supply chain and price volatility. But when we average all of this out, we land at a highly respectable final score of 8.3 out of 10. And that brings us to our final verdict. With an 8.3, tin officially lands in the high B tier. It is a brilliant ancient enabler. Honestly, it might not have the standalone brute strength to reach the A or S tiers like iron or concrete, but it is the quiet, totally reliable team player that connects and preserves our entire digital world today. But hey, I want to turn this over to you now. Think about the fact that this material gave us bronze weapons in 3000 BCE, and now it literally solders the motherboards of our 21st century servers. Does tin's 5,000-year uninterrupted service to humanity deserve a higher rank? Was an 8.3 just a bit too harsh for the metal that quietly connects the entire world? Think about that the next time you pick up your phone. Thanks for joining us, and we'll catch you in the next explainer.